In this video, we're going to learn about encoders. An encoder is a combinational logic subcircuit. It is composed of 2 to the n inputs and n outputs, okay? It performs the opposite function of the decoder. So in an encoder, only one input variable should be a 1. This is what we call one hot encoded or one hot encoding, okay? And the output represents the binary number that tells you which of the inputs is equal to 1. So we have the truth table on the left side. Only one of the inputs, it's a 1. It could be either the W1 or the W2. So only one of the variable inputs is 1. And then on the right hand side, the green columns, we have Y2 and Y3, which are the outputs. So for example, if W1 is on, then a binary number representing a 1, which is 0, 1, is what is going to be output. So for example, now if we turn on W3, which is the 3, input 3, so we're going to have a binary number of 1, 1, which is the 3. And so this is how it works. And on the right hand side, we have the block diagram. So left side inputs, right hand side outputs. Now, a priority encoder is the similar device as an encoder. In this case, the only difference is that we are looking at the most significant bit first. So if the most significant bit, in this case, the W3, for example, is a 0, then we look at the next one, the W2. So for example, if we look at this one, this row, we see that it's the first one is a 0, the second one is a 0, then we encounter a 1, and then we don't care about the rest. Okay, so in this case, we encounter a 1 first, and then we don't even care what these are. We could be 0, 1, 0, 1. We're always going to look at the most significant bit. Okay, and then, so for example, in this case, we have y1, y0, but we also have another output variable, which is the c. That's going to tell us if, for example, none of them are 1, then c is equal to a 0. Okay, and we usually don't care what we output here as long as the c is a 0. Now in the other cases, with the c is a 1, that indicates that we do have one of the inputs on, or one of the inputs is a 1. So how do we design for this encoder? So the first thing you're going to notice is that we have 4 variables. So 4 variables, we should have 16 rows, right? In this case, we're only showing 1, 2, 3, 4, 5 rows. But if we wanted to do the complete K-map, then you can expand and then do a K-map. But we're gonna do another short method. So in the case of Y1, when is Y1 going to be a 1? In this case, Y1 is going to be a 1 as long as W3 is 0. Always, right? If W3 is a 1, then we're already looking at the next at this row. But in the case of W1, W3 has to be a 0, and then W2 has to be a 1. After that, we don't care about the variable, so we don't add it. What about other case that is also going to be a 1, Y1? So we have or W3 is also a case when W3 is a 1, we don't care about the rest, Y1 is also going to be a 1. So what about the Y0? Y0, we're just going to look at this one. So in that case, we have W3 has to be a 0, W2 has to be a 0, and then W1, right? Also, in this case, plus W3. So that's how we can design. That's like a short way of doing it without having to look at all the table. What about the C? C will be similar. So C, we have all of these cases. Or you can kind of say, well, whenever I have what? Whenever I have Y1, which is these two, or whenever I have Y0, actually, this is Y0 and this is Y1 and this is Y0. And what else? I'm missing this one, right? No, this one I got it, this one I got it, this one I got it. I am missing this guy. So we have an extra W3, W2, not, W1 not, and W0. So that's when C is going to be a 1, right? We're basically looking at the midterms. So an 8 to 3 encoder, how would that look like? So we have 8 is the number of inputs and 3 is the number of outputs. So how would it look like? So if we have that, remember we have 8 inputs and 3 outputs. So W7, W6, W5, W4, W3, W2, W1, W0. And those will be our inputs. And what about the outputs? So we have 3 outputs, so Y2, Y1, and Y0. Okay, so what about the table? Remember, we can only have one of the variables equal to 1 at a time. I think I'm gonna need more. So 1, 1, 1, 1, 1, 1, 1, and 1. Okay, and so the rest are zeros. So zeros all over. Okay, unless if it's a priority encoder, remember if it's a priority encoder, then this will be an X, for example. But if it's not, then they're all zeros. So since this is just an encoder, that means that these are all zeros. Okay, so now this is only showing about 8 rows, right? So whenever we have 2 to the 8, remember that's 256. So that would be 256 rows for an actual truth table with 8 input variables. But in the case of the encoder, we just need to show these 8. And so whenever this is W0, then we have a 0, 0, 0. And remember, we can also have a C. So in this case, we have the C is equal to 1. We can have another row when we can have another row where C is a 0 and all of our inputs are 0, but I'm not going to include that here. So in the case of W1 being A1, then we have a 0, 0, 1. And for example, in the case of W7, so we have 1, 1, 1. That means that the 7th input, that's the one that is on. Same for this, a 6, a 5, 4, 4, and then 3, and then a 2. Okay, so that's how it would look like. Let me put it in clean version now. So this is the clean version, right? So remember we can have another row when none of the inputs are a 0, and that can be a C equal to a 0, but for these, all of these are a 1 also. So this is how it would look like. But let's say now that we have that, how do we design for it, right? So if I just look at this output, so I would say that Y2 is equal to what? Y2 is going to be A1 when W7, W6, W5 are not, and then W4 is a 1, but then W3, W2, W1, W0, they're also not. Okay, that's the only case. If it was a priority encoder, I can ignore all of this side, right? But since this is not, I cannot ignore it. So now we have that, and then we have, again, we have this one. So we have W7, W6, not. Then we have W5, and then W4, 3, 2, 1, and 0. So like that. So I will basically be selecting each of the midterms. So that's what this is doing, each of the midterms. Okay, so now you can have combinations of these things. So if I had those two, not a combination, but let's say if I start with this guy, I can say that is a W7 so that is this is a not, and then the rest are not. Okay, what else? This last one. So you can kind of get the idea. And W6, 5, 4, 3, 2, 1, and 0, and all of them are like that. Okay, so I can kind of call these, I'm just gonna call these, I don't know, A is equal B, C, D. And so Y2 will be equal to what? A or B or C or D, right? In the case of Y1, I will have these two, which are the C or the D plus, then I will probably have to list those two. Other way of doing it is this, right? The sum of the mean terms, and then you kind of have to list the mean terms. So in this case, what is this number? 1, 0, 0, 0, 0. I think mean term 16. I think that's what it is. And then comma 32, comma 64, comma 128. Maybe I have to shift it. Actually, no, those are the mean terms. So that will be for that one and so on. So then you can implement using and OR gates or multiplexers or any other logic gates.